Hi everyone, I'm Mustafa. I'm excited to be here. For this edition of our Beginners Lab in GCP, we are going to talk about Introduction to APIs in Google. Let's get started. First, let's start our lab. Starting the lab. Just going to move forward a little bit. Open in an incognito window. Paste the details. Just going to copy this, paste it here. I understand. The overview of this lab: APIs means Application Programming Interface, and these are software programs that give developers access to computing resources and data. This lab is going to teach you the basic architecture and the functioning power of API. We are also going to cover some hands-on practice on API to complement our learning. Let's get started. The prerequisite for this lab: it's recommended that you've taken these two previous labs before to have a better understanding. However, I'm going to try my best to make sure you don't miss that. Let's keep going. Setup and requirement is as usual. We've done that. Let's start. For task 1, API, what and why. Just to reiterate the meaning of API, API is a software program that gives developer access to computing resources and data, and they adhere to specific rules and methods to clarify, communicate, requests, and responses. APIs are built with developers in mind, and they don't offer graphical user interface. The ability of API to access data and computing resources greatly increases a developer efficiency, and it makes it easier for developers to build different programs and methods or data sets from scratch. API is built on the principle of abstraction. That is, you don't need to understand the inner working or complexity of an API to use it in your environment. Let's keep going. The next one is about Cloud API. For task 2, Cloud API. Google Cloud offers different kinds of APIs, and with Google services, you can expect a whole lot of APIs. So the Cloud APIs are just the APIs that you use on the Google Cloud platforms. The Cloud API also integrates with local environments and a whole lot of other services. For the API libraries hold a whole lot of the Google APIs. So not only the Cloud APIs, they covers a wide and extensive range of APIs used by Google services, either on Google Cloud or other Google services. So for this lab, we are going to explore the Fitness API. Let's get started. Just going to do this. Agree and continue. Under API and services, here, enable API and services. So from here, we can search for Fitness API. Click on Fitness API. Then enable this. It's enabling. So you can see it's enabled. You can just go back to be sure and search for Fitness API again. Then you should see that it's enabled now. So this is it, API enabled. Let's get to the next step. So under the APIs and services, under API and services, enable API, let's click on Fitness API. It's going to go back to our API and services. Got it. Enable API and services. Click on this. Fitness API. It's enabled. Yeah, our API is enabled already. Good. So we've got it here. So let's check the request part. Let's check the quotas and the limits for this API. You can click Manage this API. So when you click on Manage API, you can check the quotas. Yeah, next, done. So this is the limits for requests per day: 864,000, requests per minute 600, requests per minute per user. We also have 300. That's good. Let's test our understanding of this. Offers quick access documentation and configuration options for 200 plus Google API. We can guess that. That's the API library. Details your project usage of specific APIs, including traffic levels, error rates, and even latencies. That's the API and service. Correct. So you can take a look at it here under the API and service. You can check the metrics. You can see this graph, this because we are not using it at the moment, to see how well it is showing and how well it's in use at the moment. I keep going. For the API architecture, the API architectures are a set of methods that allow programs to communicate with one another. To communicate effectively, programs need to adhere to a clear protocol that governs the transfer and interpretation of data. For the client-server model, the client-server model majorly works on the principle of the internet. It's also a basic foundation for the web-based API. The clients are computing devices like smartphone, laptops that make a request for some computing resources or data, while the server has or the computing resources stored in it. The job of the server is to interpret and fulfill a client request. So the clients make the request to the server, and the servers interpret the request made by the clients. That's the principle that governs the client-server architecture on API. For task 6, the HTTP protocol and request method. The HTTP protocol majorly falls on the principles of the internet, whereby data exchange between clients and servers. It is standard for web communication where data is sent and recovered over the internet. And the HTTP uses verbs for its operation. One of the verbs that it uses is the GET request. The GET request is used by client to fetch data from a server. If the resources requested is found on the server, it will be sent back to the client when the client uses a GET request. We also have the PUT method. The PUT method replaces existing data or creates data if it does not exist. And the PUT method is also idempotent, which means if you do it multiple times, you only have one result for doing it. We also have the POST method. The POST method is used primarily to create a new resource. So using POST many times, we add data in multiple places on the server. This is to show that the POST method is not idempotent. So it is majorly recommended when you want to create new resources, while the PUT method is used or is recommended when you want to update resources. And the last common verb also is the delete method. The delete method will remove data or resources specified by a client on the server. Let's test our understanding one more time. A computing device, e.g. a smartphone, laptop, etc. that makes a request for some computing resources or data, we can guess that clients. Correct. An HTTP method commonly used for creating resources. We can guess that. That should be a POST method for creating new resources. We use the PUT method when we have to update resource, and we use the GET to get resources on the server, while the delete is to remove resources from a particular server. Next up, we have the endpoints. API uses endpoints for communication channels. So API are access points to data or communicating resources hosted on the server, and they take the form of an HTTP URL. So endpoints are majorly in a format whereby they are added to the API-based URL. So an example is the http.example.com. So if you want to check store locations under example.com, you use something like this as the endpoint. So we also have a whole lot of valid endpoints. An example is this. That is, I'm checking the store location under New Delhi on example.com. So these are just a few examples of endpoints on our API. And the endpoints announce that the HTTP verb are acted upon. So you can see if the HTTP verb is to act upon San Francisco store location, you're just going to use an example of this as your endpoint. So endpoints are specifically nouns that the HTTP verb acts upon, and they allow for access to resources without complication or irregularity. Let's keep going. Let's talk about the RESTful API. So the RESTful APIs are the APIs that utilizes HTTP protocol, request method, and endpoints. The RESTful API is the mostly common framework for API, and it is used in most API or in most client-server relationship. So there are resources that are stored in the data store. A client sends a request that the server performs a particular action, such as CRUD operation, and the server gets the request from the API. So for the REST API, they are majorly stored in JSON or XML formats. And the RESTful API data comes in two formats. We have the headers that recognize the parameters that details the HTTP request itself, while the body refers to the data that the client wants to send to a server. And they are majorly in the JSON format or the XML format. For tax9 API data formats, let's talk about the JSON format. So the JSON format holds data in the body of the HTTP request. And JSON stands for JavaScript Object Notation. So the JSON supports different formats. We have the number, we have the string, we have the boolean, we have the arrays, and we have the null request. An example of a JSON is the key 1. We also have the value 1. We have the key 2. We also have the value. So JSON more of uses a key value pair, whereby you have the key and you have the value. A JSON object uses curly braces to group data that are arranged in key value pairs. The following is an example of a valid JSON. So here is an example of a valid JSON. Likewise, we have JSON validation tools across the web that serve the function of validating our JSON that we are using. So an JSON validator is JSON lints. So I'm just going to open it here. So for the JSON lints, we can use it to validate JSON and see if the JSON is actually valid. I'm just going to use it for two examples. I'm going to paste this, then validate JSON. You can see this is an example of a valid JSON. So let's copy another JSON which is a little bit bad, and you will notice the error. Just going to copy this, replace it with this, and let's validate this JSON. So you can see we omitted a comma after the first key value pair, which is name and name, which is Julie. So I'll validate the JSON, and you can see that the JSON is now valid. That's just a good example of JSON lints, because there are a whole lot of JSONs that take a whole lot of lines, thousands and billions of lines, and going over them to get where the error is maybe a little bit taxing. So you can use JSON validators. A good example is the JSON lints shown previously. Let's test our understanding a little bit. Let's point to data or computing resources hosted on a server, and they take the form of an HTTP URL. What's an example of that? That should be endpoints. Correct. An architectural style that prescribes standard for web-based communication. That should be a REST API. A file format that is lightweight, easy to read, and fast to parse. That's a JSON format. Submit. For task 10, creating a JSON file in the Cloud Console. So let's go over how to create a JSON file in the Cloud Console. And we'll be using the Cloud Storage REST or JSON API as an example. We'll be calling it to see how far we can go. So let's open this in our incognito window and manage the API from here. So click on API enabled already. It's enabled for us as part of the requirements for this lab. Let's click on manage. After clicking on manage, we have to open our Cloud Shell and run this command. So to open our Cloud Shell is provisioning. Continue. It's provisioning our Cloud Shell instance, and it's also connecting to our Cloud Shell instance. I'm just going to wait a while for it to get sorted out. Thereafter, I'm pasting the code here. It's going to open a nano editor for me, and I'm going to paste the details here. So these are the recommended details that we had when creating a bucket. Paste this here. going to paste this here. After pasting this here, then I'll go out of the nano with Ctrl X, Command X. So you can use Ctrl X, then click on Y, enter. So we've left nano part. So thereafter, we want to talk about authentication and authorization. So authorization covers two different things. Authentication refers to the process of determining an identity, while authorization refers to the process of determining what permission an authenticated client has set for a set of resources. So in the nutshell, authentication identifies who you are, while authorization determines what you can do. Let's keep going. And we have different types of authentication and authorization services that Google API use. The three major ones we'll be talking about are the service accounts, the OAuth, and the API keys. Let's start. For the API keys are secret tokens that usually come in the form of an encrypted string. API keys are quick to generate and use, and they are best for when you want to access public data or method and you want the developers to get things started quickly and fast. For the OAuth tokens are similar to API keys, but they are more secure in the sense that they are used primarily when APIs give a developers the means to access users' data. So the major difference between the API keys and the OAuth keys are the API keys give developer access to all of an API functionality, while OAuth client IDs are based on scope. So you can grant different privileges to different identities. So let's go to the service account. A service account is a type of Google account that belongs to your application or a virtual machine instead of an individual or users. So the application assumes the identity of the service account and calls the Google APIs. So that means the users are not directly involved in the communication. For the next task, which is to authenticate and authorize the cloud storage JSON REST API. So you're just going to open this in a new tab. Let's open in an incognito window. After opening that, let's go to the cloud storage API. It's going to go cloud storage API. Here we are, version 1. Then you click on full control. So that click on the authorized API. So this is our user ID. I'm going to allow this. After allowing this, I have to change authorization code for tokens. So when I click on exchange authorization code for tokens, the access tokens. So I'm just going to click on this step 2 and copy these access tokens. You have to copy these access tokens, so make sure you copy it from start to finish. If not, it's going to throw an error. So I'm copying this. I'm just going to save it here so that I can have access to it when I need it. It's back to our instruction. Thereafter, we have to create a bucket with the cloud storage JSON API request. So that was creating it manually, we'll just send a request to the cloud storage JSON or REST API, and it's going to create our bucket for us. So the first step is to export this. So you can run an ls on our command prompt so that you can get the values that are here. So let's see. Back to our cloud shell. It's provisioning our cloud shell. It's connecting. You can also get our cloud shell from here, and we connect to this anyhow. So just ls. So it has listed the values here. Then we paste this here. After pasting this, then we replace this your token with the token that we copied. So I'm going to repaste it with this one. Let's skip this, replace it with this one here. That's a Ctrl A, Ctrl C to replace it. Then I'm going to paste it here. Then save. Yeah. So just after that, I also export our project ID and rename it with our project ID. So for this case, I'm going to rename it with our project ID. So these are just setting environmental variables to this particular thing, so we don't have to type all this thing every time we need them. We can just we can just type the whole underscore token, and we can also just type the project ID to get our project ID when we need it. So I'm going to copy this, then I paste it here, and I click on enter. Thereafter, I have to call this cloud storage API to create our bucket for us. I'm going to paste this here. So it's saying invalid bucket name. Just going to go back here and edit our nano.json and change this bucket name to a recommended bucket name. To come here, paste this. After this, to use our project ID, which is unique to represent the bucket name. It's going to use this, which is here. Copy the project ID. Replace it with our project ID here. So thereafter, I'm going to use Ctrl X, Y, and enter to save that. So after saving that, I can call this request once again. Then it should get generated. So it has created our cloud storage bucket for us. Let's check if we've created our cloud storage bucket. We've created that. Another thing we can also do is we can upload a file using the cloud storage JSON API. So I'm going to save this image so that I can use it when I need it. Ctrl C. Thereafter, save this image. Replace this with here. Then click on save. It's saved already. Then I go to our cloud shell to check the path for this. So I have to upload the image. Choose a demo image, open, then click on upload. It's uploaded. After uploading, I have to check the real path, the path of the image uploaded. So I paste this into our Cloud Shell instance. After pasting this into our Cloud Shell instance, we can check the path here. And I copy the path to this environment variable. So I'm going to change the demo image path to this. Let's copy it more comfortably. Then I paste it here. Then I click on enter. So thereafter, I have to export the bucket image. Export the bucket image name. Here I use my project ID as the bucket. So I put it back here. And I click enter. So I've exported those two names under. And I can run this also to upload the demo image to our cloud storage bucket. So the cloud storage JSON API. So it's uploaded to our cloud storage bucket. Thereafter, we can check it on our cloud storage bucket to be sure. So I'm just going to search for bucket here. About bucket on cloud storage. And you should see the image that we uploaded here. So here we are, we have the demo image on our cloud storage bucket. So that's a wrap of our lab for today. This lab is theoretical, and I'll advise you to read over it. So you don't need to have any credits to read over the lab. So you can just click on the link in the description below and read through the theories and the explanation of APIs to have a thorough understanding of what API means and how it can help you in your day-to-day activities as a developer, or just to make sure you get the data you actually need. So that's a wrap of our lab. If you enjoyed this lab, let me know, like it, comment, and also share to your loved ones. Likewise, you can go a little bit deeper to learn more about API and services to have a thorough understanding of how you can leverage on APIs and how APIs can make your work easier. Thanks very much for staying true. Do have a nice day further. Bye.